Energy through the ecosystem. We'll start with the law of energy, which is also known the law of thermodynamics. So you have to reference that word and unite it with energy. So put slash energy. I mean, obviously energy is all over the page. Anybody know? It's divided into two laws or two parts of the law. The first part says what? Correct. Only what? Transformed, rearranged, changed, okay? Now, every time energy is transformed, three things happen. Energy is lost as what? Heat. Good. Heat always flows in which direction? Look at the picture. What do you think that represents? Hot to cold. Good. Heat always flows from hot to cold. So where there's more heat to where there's less heat. And whenever you have that transformation, what happens to the system? Look at the molecules. This is after energy is transformed. Anybody know what that describes? They kind of do. It starts with an E. It's another word for like chaos, like the molecules go and get entropy, good. They go and get all chaotic and crazy in a sense, like spreading out, and that's called entropy. When energy travels through the ecosystem, it starts where? Where does our start of energy begin? On Earth. In the sun, okay, so which is a type of energy. And how does it end? Remember we talked about this when we talked about matter? Heat. So what kind of system is energy? Matter's closed. What's energy like? Open. Because it's not only on Earth, okay? It travels everywhere. Now there's 6 forms of energy that transform. So we start with sun always, right? It comes to Earth and then it starts transforming into different forms of energy somehow. Because energy can't be created or destroyed, right? It has to start from somewhere. So give me examples of other forms of energy. Chemical, good. Food and gas is considered chemical energy. What else? And if you notice, I put in orange, the chemical energy is potential, and then blue, which is all the others, are kinetic. Electrical, good. Nuclear. And what's the last one? Wind, which is what kind? Energy of what? It is a type of kinetic. So is this, so is that, so is that. Energy, wind is what kind of energy? Energy in. What's it doing? Movement or mechanical is what it's called. Energy of motion I was looking for. What? An open system, who can answer? And say it loud so the video can hear you. Sam.
It starts out of Earth, so we get our energy from the sun, and then it enters the atmosphere, and then it exits the atmosphere as heat.
Good. So energy starts out of Earth, and then once it's transformed, flows out of Earth as heat, or is lost as heat, like the lost states. I just want to go back to the slide and tell you, every time energy is transformed, always remember that the same amount of energy you put in, you get out. What's different is, by definition, anybody know the definition of energy? The ability to do work. So its ability diminishes. That's why they consider it lost energy. If energy can't be created or transformed destroyed, think about it. Even the transformed energy goes somewhere. So that lost energy and the useful energy equals the input. Does that make sense? What you put in terms of amount is the same you get out. You just lose its ability to do work. Yes?
So then can you transform the output to become like...
Sometimes we can transform the output, but eventually if you transform too much, and that's what this whole unit is about, so much is lost because every time you transform energy, 90% is lost. So its usefulness or its ability to do work diminishes quite rapidly. And you're going to see that in the next slides. All right, so the main focus of this section is how it travels through living things. And we know that It starts with what? Sun. And then what happens? Who uses the sun's energy? Plants is one example. Who else? Or what process do plants use the sun's energy? Photosynthesis. Good. And we'll talk about that tomorrow, the actual process. When plants use the sun's energy in a process called photosynthesis, what are they doing? Good. They're converting to make glucose, which is what kind of energy? Chemical. Good. Which is food energy. What do we call organisms that can make their own food? Autotrophs. And what's another word? The elementary version. Huh? Photosynthetic is an example. What's another word for autotroph? Correct. Producers. Now, there's other forms of autotrophs. Plants use solar or light energy to make their own food or chemical energy. So the transformation goes from solar to what? Solar to what form of energy is food? Chemical. So they use the sun's energy and make chemical energy. And what's lost? What form of energy? Heat. Okay, every time that happens, heat is lost. But other organisms do this without light. What are they? And there's a picture of where they're doing it. Chemosynthesis. Who does it? Bacteria. Good. Bacteria also make their own food in a process called chemosynthesis. And I'm just going to open this up. Actually, we'll go over those reactions tomorrow. So we'll stop here.